Hi friends, welcome to my channel Civil 3D Pro Designer. If you are surveyor, then this video is just for you. Do you know that how can we calculate polar coordinates and rectangular coordinates in the field, and what are the horizontal and vertical controls in civil site? If you don't know, please wait and watch complete video. Before going to video, kindly subscribe my YouTube channel Civil 3D Pro Designer, and you can also access me through my Facebook page Civil 3D Pro Designer, where you can get many more material about land surveying and also about Civil 3D. So let's go ahead for our exercise. We will learn that vertical versus horizontal control of our civil site. The whole circle bearing, what is whole circle bearing, and what is the rectangular coordinates, and what are the rectangular coordinate polar coordinates, and how can we convert these rectangular coordinates to polar coordinates, and some examples. You can see in this slide we have this one is our vertical control. Actually our elevation control is called vertical control, and when we use coordinates like northing, easting and distances, they use as a horizontal control, which we done according to our traverse. In our horizontal control, we establish our traverse network like TBM 1, 2, 3, like that. Okay, now what is whole circle bearing? Whole circle bearing is from 0 to 360 degree, and if we see that what is our quadrantal bearing, then you can say to anyone that quadrantal bearing will not more than 0 to 90 degree. First we will learn about whole circle bearing. In this example you can see here we have point A and another point we have B, which is our whole circle bearing of AB line is 280 degree, 31 minute and 45 second. As you can see, we have four quadrants from 0 to 90, 90 to 180 and 182 to 70. So A is our origin and our AB line is located in quadrant number 4. So for example, we have a network of traversing, and we are going to calculate distance and bearing between any two lines. Then we will draw something like that, and if we have our horizontal whole circle bearing, then we can calculate our angles, interior angles, and we can also calculate our external angles. The whole circle bearing extracting rectangular coordinates of a construction drawing and converting to polar coordinates for setting out purposes. Now what are our rectangular coordinates? For example, we have a chart. This one is our easting and this one is our northing direction, and these 10, 20, 30, these are our distances. It can be in meters and feet also. We have just one point with easting and northing. We need another point. If we draw our coordinates with for different points, then it will show on graph like that. It's actually not graph, it's our grid. So if we are taking 0 anywhere here or something here on any grid, so we can draw according to grid. Now we will see that how can we convert rectangular coordinates to polar coordinates. Coordinates expressed as whole circle bearing and distances, they called polar coordinates, and coordinates expressed as easting and northing, they called rectangular coordinate. For setting out purposes at site, we must need to convert rectangular coordinates to our polar coordinates. For example, we have point A and point B, and we have easting and northing for all of them. So we will follow 3 steps to calculate the polar coordinates. The first step, calculate the quadrant bearing, then second, calculate the whole circle bearing, and another third, calculate the distances. So in the first step, calculate the quadrant bearing. We will define our we will find delta easting and delta northing to minus these two easting and then another two northing. Then we will get delta easting and delta northing, and then we can take shift 10 on our calculator to get these bearing for line AB. It will our quadrantal bearing. Then we will see which one is our quadrant. According to our coordinates, our delta easting and delta northing, we are minus in easting and we are also minus in northing. So our first quadrant is plus for easting and plus minus for second quadrant, and another third quadrant we have minus. So it means we are in our third quadrant. Later, it's very important if you are newbie in surveying that if we get quadrantal bearing in our first quadrant, we will do nothing. If we go in second quadrant, we will add 180. If we find our bearing in quadrant third, we will add 180 as we have get in this example. And if we are located in fourth quadrant, we will add 360 degree. Once we find our quadrantal bearing, then we will calculate the whole circle bearing with our quadrantal bearing, which is mean that we will plus 180 because we are located in third quadrant to get our whole circle bearing. Now step number 3, calculate the distance. We have a formula, Pythagoras theorem, to calculate the distance. We have two distance, delta easting, delta northing, and yes, we can calculate our hypotenuse using Pythagoras theorem. So these are our polar coordinates of line AB. Polar coordinate consist whole circle bearing and distance, while rectangular coordinates consist on easting and northing. Here we have example, same like we have done above. It's your assignment, you can do it, and I will put this PDF book in my description link of this video. You can get them and practice, and you can learn with these examples. Hope you like this video. If you are new, please subscribe